So we're talking today about precision and significant figures, okay? And two things that we need to talk about is accuracy. And just accuracy is the degree to which a number that you get or a calculation, a measured value, okay, is actually correct, how close it is to the actual value, okay? And the precision is the degree of detail, okay, in which a value is reported. So how many decimal places, okay? So this right here is accurate. So for pi, 3 is accurate, but it's not very precise. So let's write that, okay? So it's accurate, but not precise. Okay. Here we have pi is 42.71724. Well, that's not accurate, but it is very precise. And the reason it's very precise is how many decimal places. Okay, so this one's not accurate, but is precise. Okay, and this next one, pi is about 3.14159. Okay, that is accurate and precise. Okay, so I'm going to go and we're going to weigh some of my coffee that I use in the morning. So what I want to talk to you guys about today is precision. And what I have here is a really inexpensive scale from Amazon. And I have my coffee that I use in the morning for my espresso. Okay, so I'm going to add this to the paper as much as I can without it going off the paper, because I want to transfer this in just a little bit. So we're talking about precision, and how precise is this? So I'm probably going to stop right there because it might be coming off, and maybe try to get a little bit more on this side. All right, so that's probably good enough. Okay, so I'm reading right now, this is 13 grams, right? Okay, so I'm going to take just a little bit off. Okay, so I'm taking this off, right? So shouldn't it be less? And why isn't it less? And the reason it's not less is because this is not very precise. This scale is not very precise. It's good enough for my coffee in the morning, but it's not very precise. So I'm going to get another scale that's a little bit more precise than this one. So what we measured on the scale is we have 13 grams, right? Okay, so it's not exactly 13 grams. That's actually an estimated value, all right? So what it is, it's rounding to 13, okay? So our weight here, okay, or our mass, all right, could be anywhere 0.5 either way of 13. So it could be anywhere from 12.5, because if we round 12.5, we get 13, okay, is less than or equal to m, and m, little m here stands for mass, and is less than 13.5, because if it was 13.5, now it has to be less than, okay, so if it's 13.5, all right, then that would make this become 14, and so that wasn't what the scale was saying, right? All right, and so let's go and let's grab the next scale, okay, and weigh our coffee, the same coffee, with a more precise scale. So I got another scale from the science department, okay, all right, and what I'm going to do now is I'm going to put the coffee that was on that previous scale that I got from Amazon, all right, and I'm going to add the coffee to this. And I'm going to try to get it so none of it comes off the paper. I'm probably going to lose a little bit of it. Okay. So, all right. So this one's a scientific one, right? And this is a more expensive one, and it's 14.4. So I'm going to talk about this in just a little bit, but this isn't, the previous one wasn't very precise and it wasn't very accurate. This one's going to be more accurate. Okay. So we have 14.4 grams. All right. Now, I'm going to talk about in just a minute what the range of values is. This is not exactly 14.4, just like the last one wasn't exactly 13. Okay. So that's what we talk about precision is how many decimal places we go. So I'm going to go get one more scale that's even more precise than this one. Okay. So our second scale reported a value of 14.4 grams, okay? And like I said, this first scale wasn't even accurate, okay? So what this means is that we're 0.05 away from this. So our value is somewhere in a range, okay? So it could be anywhere from 14.35, and I should put grams. You know what? I should be putting grams on this. And this one's grams. Okay. So 14.35 grams, because 14.35 grams would round up to 14.4 grams, is less than or equal to our mass, but then our mass would have to be less than 14.45. So this is 13. This first one was 13 grams plus or minus zero. I'm sorry. Yeah, plus or minus 0.5 grams. And then this one was 14.4 grams. And this is how we say the uncertainty of this value. And it could be plus or minus 0.05 grams. Okay. And 0.5 there. Okay. So let's go to the next scale and see what we get for that one. This one should have grams too. Okay. That's me being the math teacher. I got to start being the science teacher. Okay. We have to have units. All right. So let's go to the third scale. It's an even more precise scale. So here's the final scale. It's to the 100th place. And I'm going to add my coffee to that one. And again, I got to go kind of slow so it doesn't go all over the place. A little static electricity probably is causing it to stick. And I don't want runaway coffee. Okay, so this one's 14.39. Okay, so the previous scale and this scale are both precise, right? Compared to that Amazon one, the cheapie, right? And so this one is, and even the air blowing right now is changing it. That's how sensitive the scale is because I have the air conditioning on. So that's why it's fluctuating. So let's call this 14. And me just breathing on it changed it. Okay, so 14, let's call it 14. Let's call it 14.39, okay? All right? So I said, and just because I wanted to be a little bit different, this is 14.39 grams. And so it's 0.005 away from this one. So that would make it 14.385 grams, because if it's 14.385, rounding would be 14.39 because our scale is rounding, okay? And so less than or equal to whatever our mass is, which would be less than 14.395. So it's not exactly this, okay? It's somewhere in this range, all right? So this is 14.39 grams plus or minus 0.005 grams. So you see how we're getting more and more precise, okay? And we're getting, our range, okay, is getting narrower and narrower, okay? All right, so all of this said, that's what we mean by precision, okay, is that this is, we're uncertain about this value right here. It's somewhere in between here, but we don't know exactly what it is. So in order to calculate things, we can't be more precise than the numbers we start with, okay? And what that's called is significant figures. Which values are significant? And how we write our numbers is going to matter, because when we write them, we're telling somebody who's reading it how accurate it is, okay? So let's talk about significant figures. So when we're writing a number that has been measured, or we're calculating a number based on numbers that were measured, okay, we need to be accurate, but we also need to have a level of precision, okay? And we need to be confident that it's correct. And in other words, we need this thing called significant figures. So when we report a number, there's some rules on, okay, which digits are significant and which ones aren't. So the next thing we're gonna do is the rules for this. Okay, so the rules for significant figures. Here's a decimal value right here. Okay, and these first zeros are called leading zeros, and these ending zeros are called trailing zeros. So if you start with zeros or you end with zeros, that's where we're gonna have to worry about some things, okay? So non-zero numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, they're always significant, okay? So those are always gonna be important, all right? Leading zeros are never significant, okay? So in this case, 0.325, okay, the zero here, because it's leading, it's not significant. So this only has 3 digits of significancy, okay? So we say this would only have 3. We're gonna throw out the 0 there, okay? This one over here, all of these zeros are not significant, okay? So 4, 5, 6, 7, those are the only ones that are significant. So this would have 4 digits of significance, okay? Any zeros that are sandwiched in between significant numbers or significant figures are significant, okay? So right here, 302, that 0 is in between digits. So this was a sandwiched. The 5.107, that 0 right there is also significant. Okay, so now zeros start to become significant when they are sandwiched in between numbers, okay? So all 3 of these, this would have 3 significant digits. This one right here would have 4 significant digits, because the 0 is sandwiched in between 1 and 7, okay, which are significant. Okay, so here, trailing zeros. So the zeros, if a number ends with zeros on the right-hand side, okay, they're only significant if there is a decimal point in the number. So 43,200 is not, these zeros at the end are not significant. So this one would only have 3 digits that are significant. Whereas 43,200 point, okay, there's my decimal point, right? So if it has a decimal point, these ending zeros are significant. So this one right here would have 5 digits that are significant. 71.00, here's trailing ones, but there's a decimal, right? So since these are trailing, this one would have 4 digits. 0.4560000, okay? So this 0 right here is insignificant. We're not going to count it because it's a leading 0, and leading zeros are never significant. So it's just the 4, 5, 6, followed by these 4 zeros. So that's 1, 2, 3, 4, 5, 6, 7. This one would have 7 digits that are significant. Okay, so back up here to this problem that I gave you, okay, the 0.00, okay, 1205602, 1000, okay, so this 0 right here and this 0 right here are sandwiched, right? They're sandwiched between numbers that are significant, so those are important. Leading zeros, these zeros right here, are not significant. These zeros on the end are significant. So it starts with this 1. That's the first digit that's significant. And the 2 is, and the 0 because it's sandwiched. The 5 is, the 6 is, the 0 is because it's sandwiched. The 2 is, the 1 is. These zeros are significant. Okay, they're at the end, right? But we have the decimal point. So this one's significant, this one's significant, and this one's significant. So that makes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 digits that are significant. Okay? So let's go down and do this first example. Okay, why don't you pause the video, try to do them yourselves, and then look at the answers, okay? So 3070, okay? The 3 and the 7 are significant. The 0 is sandwiched in between, so it's significant. This 0 is a trailing 0, and because it's a trailing 0 and there's no decimal point, this one's not significant. So it's only the 3, the 0, and the 7. So this would have 3 digits that are significant. Okay? On part B, okay, this 0 is insignificant because it's a leading one. So is this 0 because it's leading. And then it starts with the 4. That's always going to be significant. This 0 right here, it's a trailing 0, and it is significant because there's a decimal point. Okay, so this has 2 digits that are significant. Okay, and then 5002. These 2 zeros are sandwiched in between the 5 and the 2. So all of these are significant. The 1 is significant. This 0 is a trailing 0, but there's a decimal, right? So what that means is all of them are significant. So the 5 is, the 0 is because they're sandwiched. The 2 is because digits that 1 through 9 are always significant. 1 is significant. And then this 0 right here is significant also because it's a trailing 1, but there's a decimal point. So that means there's 6 digits for this one. This one is 6. That's going to be significant. This 0 is sandwiched in between 6 and 1, so that's going to be significant. This 0 is also sandwiched between the 6 and 1, and 1 is always significant. So this one has 4 digits. This one right here, the 5 is significant. Okay, so now these are trailing zeros, but there's no decimal point. So what that means is that these 2 zeros are not significant. So this only has 1 digit that is significant. This next one, 500 point, right? Because there's a decimal place there. So now this 5 is significant. Okay, and now these 2 zeros are trailing, but they are significant because there's a decimal point in our answer, okay, or in this value. Okay, so we know we're accurate to 500 at least. Okay, so the inaccuracies, I should have said this, the inaccuracies come after these numbers. Okay, so after the decimal place. So I know I'm accurate to 500. It's not something that is between 450 and 500. Okay, or 550. Okay, so this one has 3 digits. So that's the very first thing in significant figures is we have to figure out, okay, how many significant figures are there in the numbers that are being reported? And this is how you do it, okay? You use these rules. So I want to say one more thing about this, okay? I want to talk about the proper way of writing scientific notation. So when it's done correctly, scientific notation actually reports all the significant figures. So when you're given a number in scientific notation, you know the number of significant figures, okay? So right here, how do we write this as in scientific notation? Okay, so there's a decimal just to the right of this 0. So we need to move it 1, 2, 3. So this number would be 3.07 times 10 to the, and we moved it 1, 2, 3 places, right? And see how this is reporting 3 digits, okay? So this one right here should only have 2. Okay, so this would be 4.0 times 10 to the, okay, so now this is a small number, right? So our exponent's going to be negative. So we need to move it to the right 1, 2 places. So this would be times 10 to the negative 2. And see how this has 3 digits. This one has 2 digits. This one is going to have 6, okay? So we need to make this, move the decimal 1, 2, 3 places to the left. So this would be 5.00210 times 10 to the, and it was 1, 2, 3, 10 to the third, okay? So you would write all of those, even that last 0 you would write, okay? And all 4 of these. So this one would be 6.001 times 10 to the, and it would just be first power because we just need to move it to the 1 places to the left. This one, okay, so there's not a decimal, so our scientific notation isn't going to have a decimal either, but we would need to move it 2 places to the right. So this is just going to be 5 times 10 to the second power because I would need to move it 2 places. This 500 point, okay, so now the decimal's there, so I'm going to move it. All 3 are significant, so we'd write this as 5.00 times 10 to the, and this would be 1, 2, so 10 to the second. Okay, so like these look like they're the same number, but we actually know this could be a number anywhere between 450 and 550. All right, so that's why this is important. So this, I should say this is a number, okay? I'm gonna let X be the number, okay? So this could be, this is telling me that our number is 450 less than or equal to X, which would be less than 550. Because 550 would actually round this to 600, right? Okay, now this one's telling us something totally different. This one's actually telling us this is between 400, it's 0.5 below this. It's 0.5, the next place value. So this would be 499.5 less than or equal to X, which would be less than 500.5. Because if it was, we can't include this one, because if it was 500.5, that would round this to 501, and we wouldn't have 500, we'd have 501. Okay, so that's why, look at the difference in these, okay? And it all has to do with the having a decimal place and not having a decimal place. This is a huge gap between here, and that's what's important. Don't worry about that. Don't worry about writing this, okay? But there's a huge gap here. That's what I want you to understand. Writing it this way, there's a lot of numbers. There's a lot of error in this. Whereas this one, there's not as much error. We're more precise with this measurement than we are with this measurement. That's the whole point of this, okay?